Hi everyone, this is the notes for 7.2. So last class we talked about area and how to find the area of parallelograms, triangles, and trapezoids. Today we're going to talk about how to find the area of a regular polygon. So first we need to fill in some vocab. So our formula is 1/2 AP, that's a capital P. It stands for perimeter. And the A stands for apothem. And we'll talk about in a second what that is. So a regular polygon is any polygon where the sides and the angles are the same. They're all congruent. And we've talked about this for a long time now. We're going to talk about the radius of a polygon. And that's from the center to the vertex or a corner. And then the apothem is like the height. So it goes from the center to any side. So remember, it's going to have to be perpendicular because that's what the height is. Okay, so if we look at our diagram, we can see all of those things that we just talked about. So here's our center. Our radius goes from the center to a vertex. So for this polygon, there would be 5 radiuses, radii. And then our apothem goes from the center to a side, and it's perpendicular, so it's like the height. So when we find the area of a regular polygon, we just plug it into that formula, 1/2 times the apothem times the perimeter. So remember, the perimeter is the distance around, so if you know one side, you would times it by how many sides it has to find that total length. So for our first example at the bottom, they gave us a regular heptagon. So we're going to use the formula we just talked about. Area is equal to 1/2 times the apothem times the perimeter. So from our diagram, we can see that the apothem is equal to 12. And then to find our perimeter, we would take the length of one side and times it by how many sides we have, which is 7. So 14 times 7 is 98. So our perimeter is 98. So now we just plug those numbers into our formula and do the order of operations. So we would have 1/2 times the apothem times the perimeter. So we end up with having an area of 588 centimeters squared. So very good. Let's go and work on some problems that get a little bit more difficult. Okay, so for our next problem, it says to find the area of the triangle that has a radius of 10. Okay, so we were just given the picture of the triangle, so I'm going to draw in a center so I can draw in my radius. So they told us that that was 10. So that doesn't really help us much because we need to know our apothem and our perimeter. So I wrote out some steps of what we're going to do. So we're going to find the apothem, we'll find the perimeter, and then we'll use our formula. So the way that we're going to find our apothem is because we know that this triangle is regular. So all of those angles in it are all 60. But on this side where I drew my radius, I could have drawn it anywhere. But on this one where I drew the radius is bisecting that angle, so we know we have each one of those angles being 30. And if we draw down our apothem, remember it makes a right angle, so then that would be a 60. So if you look and see what we created, we made a 30, 60, 90 triangle inside that equilateral triangle. And we could have done this anywhere. So there's actually 6 of those six of those 30, 60, 90 triangles in there. And we're going to use our 30, 60, 90 formulas that we learned back in chapter 5 to help us find the length of that apothem and then the length of this part of the base so that way we can find the perimeter. So to start, I'm going to take that little triangle that I drew, that baby triangle, and I'm going to draw it to the side so that way it's easier to figure out all those things. Okay, so we have our 30, 60, 90 triangle in there. So remember our formulas. Across from 90 is 2x, across from 30 is x, and across from 60 is x root 3. So they gave us the 2x side, so 2x equals 10. So that means x is 5. So I can plug that back in on all the sides and have all their measurements. So if that part is hard for you, I would go back and look at your 5.2 notes to try to remember those formulas. So if we take what we just figured out from this one, let's plug it back in over here. So we now have that the apothem is 5, and then this part at the bottom is 5 root 3. Right, so we have apothem equals 5. Now we need to figure out what our perimeter is. So we know we have 3 sides, so it's going to be 3 times whatever the length of that side is. So our 5 root 3, remember, is just this part of our side. It's not the whole side. But what's this part going to be? Good, it's the same thing because we split it in half there. So if that side's 5 root 3 and that side's 5 root 3, that means that the whole thing is 10 root 3. So one of the sides of our triangle is 10 root 3. So that means our perimeter would be 30 root 3. Another way you can do that is once you find that 5 root 3, what I like to do is I times it by double the amount of sides because each side would have 2 of those pieces. So we could have done 5 root 3 times 6, and I still would have got 30 root 3. So our last step is to use our formula. So half apothem times perimeter would be half times 5 times 30 root 3. And the problems that come out with radicals, we're going to just leave those in there. So really you just have to focus on timesing those numbers. So since I can't take half of 5 and get a whole number, I'm going to take half of 30. So half of 30 is 15. So 15 times 5 root 3. 15 times 5 is 75. So our answer would be 75 root 3 inches squared. Okay, so again here, if you missed that, I took half and I times to the 30 first because half of 5 is a decimal. So half of 30 is where I got the 15, and that 5 stayed there. 5 times 15 was where we got the 75 from. Okay, very good. So let's try another one, the one next to it, the hexagon. So this one is going to end up being very similar to the one we just did. So this one, though, they told us our apothem. So I'm going to draw in my apothem. Okay, so our apothem has a length of 12. So we need to know the base part so we can work on finding the perimeter. So if we fill in our 30, 60, 90 formulas, this side is x root 3 and that side's x. So we just have to solve this for x. So remember, we make them equal. X root 3 equals 12. And then we will divide by root 3. So x equals 12 divided by the square root of 3. So remember, we'll simplify that by timesing the top and the bottom by the square root of 3. So we end up with 12 root 3 over the square root of 9, but the square root of 9 is 3. So this would be 4 square root of 3. So that means this part is 4 root 3. So that means that if that part's 4 root 3 and that part's 4 root 3, that our whole side will be 8 root 3. So we have an apothem length of 12, which they had given to us. And then we have perimeter. Each side is 8 root 3, and we have 6 sides. So that means our perimeter would be 48 square root of 3. So now I just need to plug them in the formula. So the area is equal to 1/2 times the apothem times the perimeter. So for this problem, since I know what half of 12 is, I'm going to do that part first. So 6 times 48 root 3. And then 6 times 48 is equal to 288. And again, we're going to just leave the radical hanging out there. We're not going to do anything to it. And then we put in our units. Okay, very good. So, I'm sorry, I forgot to mention how we knew that this was 60. There's a couple different ways to figure it out. One would be knowing what each of the angles is inside the hexagon, and that was that formula we learned last chapter, 180 times n minus 2 over n. If you did that, you'd get 120. But remember, we cut it in half, so that's where the 60 came from. There's a couple different other ways to do it. I can talk about it in class more if you need help with that part. Just remind me to in class. Okay, so let's take a look at our square. Our square is going to be a little different. Is it going to make a 30, 60, 90 triangle? Very good, because if we are bisecting that angle that's there, we're bisecting a 45. So our side is really going to be, or our little mini triangle in there is 45. So this said it had a radius length of 8. So we're going to have to do our same 45, 45, 90 rules on this one to find out what the apothem and the side is. So remember that x root 2 goes on the hypotenuse and these sides are both x's. So if we set up our equation and do the same stuff that we did for the last one, we'll be able to figure out what our side lengths are. So I got you started. Go ahead and find out what your apothem is, and then use that to find out what your side lengths are. And when you come back, I will go over the answers, and then you can work on the last example. Okay, so let's take a look. We ended up having 4 root 2 as those side lengths. So that meant that this part is 8 root 2. So our perimeter would have been 8 root 2 times 4, since there's 4 of them. 8 root 2, 8 root 2, 8 root 2, 8 root 2. So we got 32 root 2 for our perimeter. Plugging that in, half of the apothem times the perimeter, we ended up with just 128 feet squared. So the square is not going to end up having a radical, usually. And that's because it ends up being isosceles, so you're multiplying the radical out, like what we did here. There is a couple other ways to do the square depending on what they gave you. If they give you the apothem, then you can just double it. Well, you would know that if they give you the apothem, it's the same length here. So then you'd be able to find it and just do the regular formula. And then once you find the side lengths, we could have done 8 root 2 times 8 root 2, because 8 root 2 is here and 8 root 2 is there, and it's a square, so base times height. So that would have been 64 root 4, which is 64 times 2, or 128. So the square is the best one if they only give you some of the information you need, because it's a lot easier to find the rest. Okay, so go ahead and pause and try that last triangle. It's kind of like what we did for our first example, and then when you come back, I will help you with how to get the answers if you got stuck. Okay, so they gave us our side length of 24, which meant when we drew in that little baby triangle, we had a 12 here, because that splits it in half. So we found the perimeter right off the get-go because they gave us a side length, so 24 times 3. So what we really just need to do is work backwards to get our apothem. So since this is our side that we were given, we make our equation to solve for x. So we end up with 4 root 3 for the apothem length, and then we just plug it in our formula. So make sure you write down any questions you have and ask them in class tomorrow. Werner out.